Okay, so hello everyone, and welcome back to another session. And we were continuing our database transaction and concurrency. And this is a synchronous meeting. Let's continue to the session. And in the previous session, we have gone through a lot of points, including what are the advantages and disadvantages, or say the drawback limitation that we need to take care of during a concurrent schedule, right? So right now, so far, we are quite familiar with this term. One is your serial schedule, serializable schedule. See, understand the difference between them, and keep in mind we have covered them in detail about them. And concurrent schedule. The serial schedules are those schedules in which the transactions are executed in a serial way, one after other. That is your serial schedule. Serializable schedule means the schedules which are parallel schedule, we can say. Those parallel schedules, for the for those parallel schedule, there exist some serial schedule. Then we say that particular schedule is serializable. And concurrent schedule means all the schedules which are, which can be which we can perform the concurrent execution of transactions, or all your concurrent schedules, right? So to understand graphically, let's see how we can understand difference between these. The first one is your serial schedule. The first is serial schedule. After then, what we have is serializable schedule. This is serializable schedule. And then we have concurrent schedule. Right? It means what? There are some serial schedule, right? So this serial schedule, all the schedules which are which are serializable. For example, means try to understand with this. What we can conclude is there are certain serial schedules which are also serializable, but not all schedules are serializable schedule. In the same way, we have the outer category, that is concurrent schedule. This concurrent schedule contains serializable schedule as well as serial schedules. But there are a few schedule, for example, this one. These schedules are what? Non-serializable. These are non-serializable schedules. Means what? These are those schedules which cannot be serialized. Means for the concurrent schedule, there exists no serial schedule for this schedule. Right? So this is the hierarchy we can understand about all of these three schedules in way. Right? So far so good. Now, let's understand. In the previous class, I just gave you an idea what we will do in this class. Basically, let's understand about serializability. Right, let's continuing further. How we can identify the corresponding serial schedule for any concurrent schedule. Right, that's what next topic, classification of schedule based on serializability. Right. So how we are classifying schedules based on serializability. The first is called your conflict serializable schedule. And second is called your view serializable schedule. right? So these are the two methods with the help of which we can find out corresponding serial schedule for your concurrent schedule, or say the parallel schedule, right? So we will see in depth for both of them, right? But before starting, let's go through 4 points, right? These points are very important and will be very helpful in understanding the rest of the topics, right? So first understand these points, and then we will start looking at conflict serializable, right? So first is topological short order. What is the topological order? So if you remember topological sorting you have done in your design and analysis of algorithms, you might had this course. There you saw a topic that is greedy algorithm. So this topological sorting or topological order is a part of your greedy algorithm. Why it follows greedy approach, right? It follows greedy approach. How? Understand, graph traversal algorithms are only for directed acyclic graph. Keep this thing in mind when we perform, because topological order will find out of a graph, right? So what is the approach? Will be given a graph that is basically directed acyclic graph. So for that, how we identify a topological order? See the algorithm approach: visit vertex whose in degree is 0, whose in degree is 0. We need to visit that, and what? Delete vertex v from the graph, right? The second, this is the first step. The second is repeat the first one for all vertices, right? We will get our topological order, right? So let's understand this with the help of an example. How we find the topological order, right? This is very important and will tell you where we are going to use this, right? So let's take a graph. Let me take some vertices, and in this way let us take the edges, right? So we have a graph a b c d, 5 vertices and this vertex. So identify that vertex in which in order is 0, in order degree is 0, in degree 0, sorry, in degree is 0. So understand, for a vertex we have two types of degree: one is in degree and other is out degree. In degree is basically the number of edges coming towards that vertex. Out degree is number of edges going away from the vertex, that is out degree. So understand what is in degree for over here. For this, how many in degree? We have two edges coming, two. For this one again two, for this again two, for this one, for this 0. So we have identified the vertex in which in degree is 0. Delete this. What we are left? B, C, D and E. These are as it is. So the as is going from vertex A will also be deleted. This and this. So we are left with this part and this part, right? Okay, so fine. Now again repeat the same step. For this we have 0, 1, 2 and 1. So delete B now. What we are left with? C, D and E. Now see, both C and D have 0 vertices. A 0 in degree is 0 for this two. So we can remove one after other. We have two possibilities. First we remove C, then we remove D and E. First remove D, then remove C and E, right? So now identify what will be the topological order. First, which vertex we remove? A, right? We remove first A, then we removed B, then we removed B, and then what we can remove after B? We have two options, C and D. So if we remove C first, then which one remove we? We remove D, and then we remove E. But after B, not C, we can remove D also. If we remove D first, then we have to remove C and then remove E. So see how many two topological orders are there for this graph. That is what? A, B, C, D, E, A, B, D, C, E. These are the two topological orders, right? So easy one. So in this way, we identify what is the topological order. So I'm just leaving an example as an exercise. You just try and let me know how many topological orders and even what are those, right? So try practicing this and identify how many topological orders are possible and what are those, right? Okay, fine. Now let's start the second point, right? So the second point is your conflict pair. Conflict pair. If you remember, we have seen in brief about this in your problem in the previous session, that is read and write problem. Now let's understand in depth what is the conflict pair. Now see, understand two operations pair basically between the operation, two operation from schedule S is conflict pair if and only if, double if condition. The first one, understand. The first says there exists at least one write operation. That is, at least one write operation there should be there. Right? Understood. The second, see there is AND operator. An AND means condition should be true, both. The another condition is these two operations basically should be over same data item. Over same data item. Right? Means same data item. In both of these operations, we have the same data item. We have seen in the previous sessions what are the data items, right, with the graph. And the last condition is these two operations should be from different transaction, right? These operations should be from different transactions. Whenever such type of these conditions are true for any two operation, we say these are in conflict pair, right? So let me make you understand. For example, see over here writing a schedule. There is a schedule in which we have number of transactions in this way. We encounter read of I on data item A and write of J on data item A. Right? Understand. There might be some other operation, read write on any data set. Now see read of I on data item A and write of J on data item A, where I is not equal to J. I and J are a transaction number. R1. R1, if it is 1 means from transaction T1. W2 means transaction T2 in this way. So if we have such type of scenarios, this is conflict. Why? At least one write operation. Yeah, we have over same data item. Yes, on same A from different transaction. Yes, I and J. I not equals to J. It means this is a conflict pair. The same for any other schedule. For example, we have Wi of A and Rj of A. Again, this is conflict. Both of three, all these three conditions are being satisfied. Plus another condition Wi and Wj on A, right operation. These all three conditions are conflict pair. These all three conditions are under conflict pair, right? Understand that. But there are some schedule. For example, in this we have read. If we have read and another read probably on the same on different transaction, then and also you can have read of I on A, or you can have write of I on A. You have read of J on B, or you can have write of J on B. In both of them, there is no conflict pair. See, read and read, always remember I told you, whenever there is a read and read, probably in the different transaction over same data item, there is no conflict. But here we are working on data item A and here working on data item B. So understand we have logical AND operation between these three. If either any of one is false, then probably we'll say it's not conflict pair, right? So this operation is saying what on different data item. Different data item, no conflict. That is what A and B. But these are on same data item and satisfying all these three conditions, right? So let's understand with the help of an example. Let me say if I have a schedule like this, I have read and write. Okay. See now, identify the conflict pair now. R1A. What will the conflict pair of R1A? That is W2A. Right? If other transaction W3A, W4A, it can be any. So is there any W2A? Yeah, it's there. So it means what? Both of them are what? Conflict pair. Is there any other conflict pair? Okay, understand. R1B. Conflict pair will be W2 or W3 on B. This is right next. So this is what? Conflict. So these are what your conflict pair. Right? But see, is there any conflict between R1A and W2B? No. Why? Because between these two, we have read or at least one write operation, that's fine. On different transaction, that's also fine. But third condition fails. That is a different data item. In the same way, R1B and W2B, there is no conflict pair. Right? So in this way, identify the conflict pair over here. Fine. The easy one. So far, I hope you have understood. So what we can do right now is in continuation for this one, understand if you might have a problem over here, you might face, for example, we have written the transactions in this way. Let me show you. We are writing the transaction in tabular format, right? Means what? For example, transactions in this way, right? T1 T2 T1 T2 and T1 and T2 in this way. This is also a schedule in which we have two transactions T1 T2, right? Here also, right? So understand the other way for this one is even you can write in this way also. We have T1 transaction, T2 transaction. Right, you can write in this way also. This is schedule as where T1 and T2. How will write R1A? That is read from first transaction on date item A. That is R of A. R1 of B, R of B. W2 of B. That is W of B. W2 of A. In this way you can write and you can find the conflict pair, right? So we can see this RAA, this pair is conflict pair and this pair is conflict pair. So in this way you can identify, but understand in the questions you will be given schedule in this format rather than in this format, right? This format will be given. So just have enough practice and just try to solve in this way, right? So there is a note for that need to understand. Always remember non-conflict pair can execute in any order. For example, let's say T1 and T2. Non-conflict pair can execute in any order, R of A and W of B. There is no conflict pair. Why? Because different data item. You can execute in any order. Let's say W of B first and then R of A. Both are equal. There is no conflict. But the conflict pair result always changes on changing the order. So always remember, we do not change the order of conflict pair. Right? For example, same in T1 and T2, we have read of A and write of A. So there is a conflict pair, read, write, conflict, right? So we cannot write this is not equivalent to this order, write of A and read of A. Both of them give different output, right? So these are never equal. So don't change the pair of this one. So I hope you have understood that is what conflict pair, right? Let's start with the third one, which is called a precedence graph. Now this is important. Precedence graph. So understand graph, then basically we have vertices and edges. So how we identify vertices? That is number of transactions in schedule S. As now understand how to find as. It's not like the previous diagram graph that we understood. No, it's not like that. It's different because the name is different. This is precedence graph, right? So how to identify the as is in case of precedence graph? Identify the conflict pair precedence of schedule S. Means here we need to identify the conflict pair now. Remember, right? Whenever there is a conflict pair, there will be an edge. Okay, so try to understand. For example, let's take an example. The schedule given with value something like this. Again, the schedule values will be given like this only. You need to have a good practice, and it's easy to solve in this way also, right? It's not every time that we will making the tabular format transactions and then start solving, right? So these are me. So how many transaction? So identify the highest value. 1 2 3 three transaction. Okay, now we need to identify the s between the states vertices, right? Always remember in this, whenever given this one will always move in the forward direction. When we are here, we will not take care of what we have left. We will see only the forward direction left operations. Okay, start from R1A. Let's start from R1A. What is the conflict pair? We need to identify the conflict pair. The R1A conflict pair will be different transaction, write operation on A, that is WA. So WA, yeah, it's there. So W2A, we have different transaction, write operation on same data item. So remember, we move in the forward direction. So the arrow will be on transaction T1 towards the transaction T2, that is T1 to T2 in this way, right? Understood? So this is done now. So just cross it. Let's now start move on this one. W2A corresponding conflict pair will be WA itself and RA, but from different transaction. So WA is there, right? Different transaction, right operation, same data item. So this is what T2 to T1. Yes or no? So this is done. Leave this. Is there any else or no? W2A, no. So just leave. There can be any. We need to check every. Okay. Now W1A. See, after this one, we need to look in forward direction. There is no data item with A. There is no operation with data item A. So simply no conflict. Now coming here, R1B with W1B. There is no conflict. Why? Because same transaction one, no conflict. But this is conflict. That is WB, R1B, W3B. That is 1 to 3. 1 towards 3. That is T1 to T3. W1B, W3B. This is again towards 1, 3. Already there, so no need. And single no. So this is what our precedence graph. right? So in this way we make the precedence graph for the given schedule, right? Okay, let me, for the timing, let me make you understand with the help of your tabular format, the transaction schedule, right? But remember, in the questions you have to have enough practice to solve in this fashion, right? For this transaction, let me write in tabular format T1, T2, and T3, right? So let's understand in this way also. But this is not, just don't keep practice for this one. Just make good practice for this solving strategy. R1A, that is RA, W2A, W1A, R1B, W1B, W3B, this way. So this is what we have written, right? So that's it. Now make the precedence graph. How many transactions? Three transactions. So T1, T2, T3. Now start. R of A. You need to look the conflict pair for this read. That is what right of A, but not from T1 on T2 and T3. So WA, R8 conflict is WA. So check. Yes, it is there. That is what from T1 to T2. So now cross it because there is no other. Now W of A. Check at W of A. Right. So W of A, what is the conflict pair? For this conflict pair is W of A itself and R of A, but from different transactions. Right. So W of A, but see the W of A is here in different transaction. That is from T2 to T1. Any other W of A or R of A? No. Right. So this is done now. Now coming up to this W of A, conflict pair is W of A and R of A from different transaction. So here no other, because W of B is what we are left. See, when we are here, don't look at the upper one because we have used them. R of B, conflict is W of B and it is there. See, so there is a conflict from T1 to T3. Close. W of B, conflict is R of B and W of B. It is there. That is T1 to T3 already there. Hence, this is done. This is last, no conflict. And this is the graph. Right? This is what we have. So always remember the practice is for this one. Keep in mind. If you find it more complex, you can just go for this one. Up to you. So in this way, we can make this graph. So let me give a questions as a practice over here. I try to identify the conflict pair. Precedence graph basically. These are the operations. Right? So R1A, R2A, R3A, R4A, W1B, W2B, W3B, W4B. So identify the precedence graph for this one, right? Okay. So with this one, our third is also finished. And now let's see the last one, that is fourth, conflict equal schedule. Conflict equal or equivalent, both same. Conflict equal schedule. What are this conflict equal schedule? Remember, the equivalent is operation is there, then definitely we should have two schedule. Remember, in this what we need to check, we will check whether the schedule to schedule S is equivalent to S dash or not. So how we find out S dash over here, right? For that, identifying non-conflict. Remember, non-conflict adjacent pair. First identify non-conflict adjacent pair and then swap them. Swap them to find S equivalent to S dash or not. Right. So understand here, we swap non-conflict pair, because we have understood now conflict pair swapping will give you different answer. Right. So let's understand this. Let me take an example and let's see how we identify the conflict equal schedules. For example, our S schedule with two transactions T1 and T2 are like this. Okay. And our S dash schedule is this. We need to check whether both are equivalent or not. Right. So this is what we have. Let's check whether both are equivalent or not. Right. So what we will do, as the concept says, identify non-conflict adjacent pair. So let's start from the bottom. Right. So let's start from the bottom. Non-conflict pair. Is this non-conflict pair? Yes. Why? Because read and write operation are there, but from different data items. Hence non-conflict. So what it says that swap them means what? Move this in up direction and move this in one direct down direction. Swapping. So what we will get with T1 and T2, these as it is, RA as it is. Now this RB will move up and WA will move down. So first RB will have read of B and then write of A. Now check again. Is this equivalent to this? No. If this no, then again we need to check for the same. Identify the what non-conflict pair. So now see the next one, RB with R of A. Are these non-conflict pair? Yes, because different data items. So swap them. Move up, move down. So this is equivalent to transaction T1 and T2. This is S. What we will get? These same as it is. Now this will move down, this will move up. That is RB first and RA down and WA. Now check. Are these S dash and S equal? Yes. See, both are same. This here and this here. Hence S is equivalent to S dash. That is conflict equal schedule. S and S dash are conflict equal schedule. Right? But understand, if I gave you some values for S, instead of giving this value, if I gave you this value T1 and T2 and transactions are something like this, can we identify the conflict, non-conflict pair in this case? See, we need to identify the adjacent. See, adjacent pair, this is important, right? So see here in this case, R and B. See, we cannot look for RB because adjacent pair, this is not available. But for W of A, we have the adjacent pair that is in this different. Are these non-conflict? No, these are conflicting. Why? Right operation at least one, different transaction over same item. Hence, this is conflict pair. We cannot swap them. That's fine. Move on the next one. W of A. Conflict pair, not this one, this. So is this conflict free? Non-conflict? No again. Same, right? Same data item, different transaction. So in this case, we cannot swap. We cannot swap because all are conflict pairs. All are conflict pair. And now in this case, if we have this S, then we say S and S dash are not conflict equal schedule. This way, right? So this is how we identify conflict equal schedules over here. See, in the book, if you will go through the books, textbooks, probably they gave you some different definition for the same. According to the textbooks, if you will go, their definition is something like this one. Conflict equals schedule. For example, S1 and S2 are conflict equals schedule if and only if each transaction, that is Ti, each transaction Ti of your schedule S1, each transaction of schedule S1, that is Ti, must be exactly same as each transaction Tj of S2. This one. This is their first condition. You will see that meaning is same. And the second condition says every conflict precedence of S1 must be same as precedence in S2. Means what? Every conflict pair, right, of that is of S1 must be same as precedence in S2. If two pairs are conflicting, right, if two pairs are conflicting, then if the first operation is coming first, then it should come first only. Try to understand. For example, I said over here in this one wa is coming first and then ra is coming next, and these are what conflicting pair. We can take any transaction in any other in any schedule, right? If we have the conflict pair in this way, this ra should not come first, ra should not come before w of a. That is what it means to say. Means swapping should not be done between your conflict pair. This is what it means to say, right? There should not be swapping. Whatever elements are coming before, that should come before, even after, in even in different schedule. Even it means we find that different, the pairwise. So this is what in the textbook probably you're gonna find the definition, formal definition. But this is the way we used to identify whether the conflict equal or no, right? So you can follow this approach. Let's solve some example in this one probably, right? So you'll be more able to understand. Okay, so example is I have given the schedules like this. Let me first write them. This is your S1. So just have practice for this one, because if you will try to write this in tabular format, then definitely it will consume time, and um this way is even better, right? So it's faster and convenient if you have uh, sufficient practice in solving such type of questions, right? So these are three schedules that we have. Now let's check out which schedules are conflict equal and which are not. So in pair, understand, we look in the pair, that is what adjacent pair. So make adjacent pair for this one. In this pair, is there any conflict? No. R read and read. Okay. For this pair, is there any conflict? No. Because on different data items. But for this one, yeah, it is a conflict. Why it's a conflict? Because they are different transaction, right, operation on same data item, right? So this is what we have understood. Now see at S2. R2A and R1A, what we have done? We have swapped them. But we have understood, we have seen that the pair which are actually non-conflict, there is no conflict, we can swap them. The order, we can change the order. So there is nothing wrong. For W1B, R3B, again we have swapped them. Okay, that's fine. W2B, W3. But the conflict pair was with this one. This was the conflict pair. We should not swap them. And see, these are not swapped. Hence, both of them are conflict equal. Both of them are conflict equal. What's wrong with S3? Let's see. R2A, R1A, okay, fine. W1, R3, this is also fine. W3B, W2B. See, these are what pair changed. these both of the operations are exchanged, right? So now this pair, this schedule basically is not conflict pair with S1 and S2. Why not conflict equal? Why we have swapped what conflict pair of adjacent conflict pairs, we have swapped them, but our conflict equal says we need to swap only non-conflict pair, non-conflict adjacent pairs, right? So this is what we say, non-conflict adjacent pair, we need to swap that, only then we have conflict equal. These are non-conflict adjacent pair. You can swap any of them. That's what we have done. But it should not be swapped. But it is done, so not conflict pair with S1 and S2. So I hope you have understood with this one. Right? So, okay. Understand? Okay. Now, okay. One more point. This is a note you need to keep in mind. Understand about conflict equal only, right? If S1 and S2 schedule are with a same transaction, right? And this is AND operation. B, same precedence graph. We have seen precedence graph, right? Again, and the third condition says that acyclic precedence graph means there should not be cycle in the graph. If these three conditions are true for S1 and S2 schedule, then we say S1 and S2 are conflict equal, right? If P, then Q, that kind of mathematical logic. So if these three are true, only then we say this. Why said this? Because understand, if S1 and S2 are with same precedence graph, right? Give you an example. Just understand, if S1 and S2 are with same what precedence graph, right? Then S1 and S2, then S1 and S2 may or may not be conflict equal, right? May or may not be conflict equal. Why? Understand, this is important, right? Not every time, because now let's say if I have schedule with T1 and T2 transaction, I have read of A, then I have write of A, then read let's say write of A and then say read of A. See, this is the execution flow, right? But understand, the execution flow over here in T1 and T2 transaction, if you try to find out the precedence graph, conflict pair, this is the conflict pair, yes or no? Right, that is T1 to T2. T2, WA and WA. This is also a conflict pair, right and right. Right, that is T2, T1. This is also, so we have already. So this is, see, this is the precedence graph. Understand? Right. But if I write the transaction schedules in this way, and read of A, write of A, write of A here and read of A here. Now see my precedence graph. See, with the help of precedence graph, we cannot sure about conflict equal. This is the the reason I'm just explaining. This is what conflict pair, T1 to T2, right? But see, this is also a conflict pair, that is T2 to T1. Both of them have same precedence graph, but both of them are different. These are not equal, right? So if we have same precedence graph, then we the schedules may or may not be conflict equal, right? These are not conflict equal in this case, but now they have same. The reason basically is, understand, we should have acyclic precedence graph, but in this case we have cyclic precedence graph, right? So this we will see in the next one, probably right after this one, right? Okay, that's fine. Now going back to the same previously from where we started, right? So we saw the conflict pair, we saw about this one, and classification. So we started with classification, right? So we understood first topological order, then we understood the second conflict pair, and then we understood after conflict pair we understood about the precedence graph, and then we understood about conflict equal schedule, right? We have covered those 4 points. Now let's see what is conflict serial schedule. The first way to identify serializability of a schedule, that is conflict serial schedule, right? So what is conflict serializable schedule, right? So to identify the conflict serializable schedule, understand what we have to do, right? First, make precedence graph. Make a precedence graph, right? So we know how to make precedence graph, yes or no? We identify number of vertices and we identify the s between the vertices, that is the transactions, right? Now understand how we identify whether a conflict serializable schedule exists or not. After this, if graph has no loop or no cycle, basically acyclic, right? Then we directly say schedule is conflict serializable, right? And also remember, and also it is consistent schedule. And whenever we perform such type of operation over the database, our database will also be consistent, right? So that is about conflict serializability. Understand now. Let's take the help of an example. Let me take some transaction T1, T2, T3 with some values. Read, let's say data item XYZ this time. Okay. So this is one schedule. Let's identify first whether this is serializable or not, right? Once it is serializable, we will go to how many, what are the serial schedules possible for this one, right? To for that, definitely we need to what, make precedence graph, right? So let's make for this one, we have three transactions T1, T2 and T3. That's fine, right? So start. Read of X, right? Identify the conflict pair. Is there any what will be that? Right of X. So no, there is no conflict pair, cut. Read of Y. Is there any conflict pair? Just leave the T3 transaction. Read of Y. So on Y we have Y. So for this also there is no conflict. Okay. Read of X. So right now we are enough, we have enough practice and we can identify the conflict pair very easily and in a faster way. For read of X we have, yes, right of X, that is from T3 to T1, right? So from T3 to T1. Okay, so right of Y, right of Y, so is there any? No, probably. Read of Z, read of Z, so there is right of Z, that is from T2 to T1. Okay. Is there anyone? Oh, no, no, no. Yeah, that's fine. Just a minute. I think there is something. Oh, it's incomplete actually. That's fine. Let's continue. So, is there anything else for read of Y? We so read of Z. We have formally taken this one, and this is what the graph we have so far. Right. for this scenario, right? Just for, let's okay, for R of Z, because there is no other operations in the transaction, there will be no conflict for any of them. We know, because for conflict we need to have values in different transactions. Okay, fine. Let me add on some values over here again. With this one, for example, what we can add is in here, if I am adding, let's say I again add Z of here, right? And again, if you proceed for this one, okay, last again for Y. Right, in continuation for this one, now see, uh, we need to check these values also again. For R of Z, we have W of Z over here. So R of Z, W of Z, there is a conflict that is from T1 to T2, right? But again, we cannot have the loop, right? Because understand, for serializability, there should be no loop, right? So instead of Z, we can, what we can take, we can take X. Right. If we can take X, then for this probably there is no conflict. But again, just try to understand. If you are taking the values, then probably we need to consider from the very beginning, right? So right now, just leave this as it is. Right. I'm going to look at this different example. So we have this precedence graph for this one. So if graph has no loop, that is no cycle, then we say this is a conflict serializable schedule, right? So there is no loop. How we identify whether there is a loop or not, right? So understand, if you are at this one, if you are at T2 transaction, you traverse any of the vertex and you come back to the same node, same vertex. If this happen, then we say there is a loop, right? And then in that case there will be no conflict serializable schedule. So probably here you can see there is no such cycle existing, right? So in that case, this set of instruction or set of operation basically is your serializable, right? This is your serializable, right? Okay, let us take another example, and in this case, okay, the question given is given schedule like this. Okay, fine. So this is the question. We have the schedule like this one, right? So we need to identify, check whether the view conflict serializable or not. Okay. So we have this. So for example, this one, let's take transaction T1, T2, T3, and T4, right? Although there is no need, but still, okay. Let me just, for understanding, we can take, although we can make precedence graph easily without making this one, right? Fine, you should have the practice in that way. But R1 of A, okay, fine. Let's make, then W3 of B, that is over here, W2 of B, that is here, W1 of A, that is here, W4 of A, that is here, and R3 of A, that is here. Okay, so 4 transactions, that means 4 vertices, right? These are. Okay, so now start. Identify the conflict pair for read of A. In this one, do we have, yeah, see, read of A is present, but these are read and read, no conflict. Write of A is there. That is from T1 to T4. T1 to T4, we have a conflict pair, right? So cross. W of B, take the right next. W of B, is there any B? Yeah, it is there. That is W of B is present over here. That is from T3 to T2. So from T3 to T2 in this way. W of B, is there any? No. All the operations are on data item A, so no conflict. W of A, yeah, it is there. R of A and W of A. See, T1 to T3 as well as T1 to T4, right? So T1 to T3 as well as T1 to T4 is already there. Now it is done. Now W of A, that is T4, and R of A, conflict pair, that is from T4 to T3. So for T4 to T3 and the rest, this is our precedence graph, right? So is there any cycle, right? So understand, if we are over T3, can we come back? No, because this is, there is no, okay, we can go to T2, but we cannot come back. From this one, we can go here, but we cannot come back to E4. From T1, obviously we cannot come back, and from T2, we cannot come back. Hence, this graph is acyclic, right? So we have understood if graph is acyclic, probably this schedule is conflict serializable. Conflict serializable schedule, right? So if this is a conflict serializable schedule, we have understood there exists some serial schedule for this schedule, parallel schedule, right? So what is that serial schedule? Let's identify this. And to identify the serial schedule, we identify the topological order for this graph. And this is for reason we have understood topological order, right? So topological order, identify the topological order now, right? So we have the graph T1, T2, T3, T4, and these are as is. Yeah, right. So topological order means in degree 0, for which for T1 we have 0 in degree. For this we have 2, for this 1 and 1. So delete T1. If you delete T1, what we are left with? T2, T3, T4, and this we are left with, right? These two as is will be deleted. So now in degree 0, this is for 1 and 1, this is 0. So delete T4. After deletion of T4, we left with T3 to T2. That is, we delete T3 and then T2, right? So what is the order? First we deleted T1, then we deleted what? T4, and then we deleted T3 and then T2. So this is what our serial schedule, right? So for 4 transaction, how many possible serial schedule? Maximum possible, that is 4 factorial we have seen. Out of 4 factorial, this is one of them, right? This is one of them. And for this parallel schedule, we have this serial schedule. So this is the way how we identify whether there is a conflict pair or not, right? So in this way we identify whether how many conflict pairs are even, because number of topological orders will be those number of serial schedule for this given parallel schedule, right? So just for a practice, you can solve one question, easy one. The given schedule is with values this way. So identify whether this is serial schedule or not. If this is serial schedule, then what is uh, not serial schedule? Basically, what is the conflict serial? Whether this is conflict serializable or not. And if it is, then identify the serial schedule in that way, right? So with this one, hopefully we have completed our the first method to identify your serializability, the classification of serializability, right? On the basis of serializability, we have two: conflict serializable and view serializable. So basically in the next class we will start with view serializability, right? And then we will move on to the next locking protocols and log based protocols. So for upcoming topics, so keep in mind this, whatever we have covered so far, these are very important and you should be having a good practice. So just make sure you have good practice, and we'll cover in the next class in the rest of the topics, right? So okay, so that is for today. will continue further in the next class. Fine. Let me know if any one of you have any issue. You can just let me know. We'll solve. We'll discuss. And also in the lecture, gave you a question. You definitely have a practice. Just have a practice of those questions. That's important. Okay, we'll see you in the next class. Fine. Let's stop recording.